Okay, the mean value theorem is just a little neat theorem that gives an explicit relationship between the average rate of change of a function. And remember, the average rate of change of a function is just the slope of the secant line. And the instantaneous rate of change of a function. For example, the slope of a tangent line. It guarantees that at some point on a closed interval, the tangent line will be parallel to the secant line for that interval. Alright, and you know from a previous math course that parallel lines have the same what? Have the same slope. Good. Alright, so what this theorem is saying that there is always some place on an interval where a continuous function is changing at exactly the same rate is changing on average for the entire interval. Alright, so according to your theorem, this is what your theorem states. If a function f of x is continuous and differentiable on the closed interval a to b, then there exists a point C between A and B such that the derivative at C is equal to slope of the secant line. And that's just f of b minus f of a over b minus a. Alright? In other words, a point C is guaranteed to exist such that the derivative there f prime of C is equal to the slope of the secant line for the interval AB, which is f of b minus f of a over b minus a. And that's basically all. So a graphical representation would be if I had, say I had a coordinate plane here, right, and my A was here, and my B was here, and my, let's say f of A was somewhere right in here, and f of B was somewhere right in here. Let's say I had some curve coming down here. Okay, I hope I can draw this straight here. Well, curvy. Yeah, that's not working quite right. Alright, had some curve here. Alright, so I had, let's say I draw the secant line here. So secant line, ooh, hope I can draw this straight. Secant line is going straight through, ooh, that was good. Going through A and B. Alright, so there exists some C that has the same slope here as the secant line. Alright, so this is my C right here. Right, so it has the same slope because it's parallel to the secant line. Alright, so remember this point is A f of A, and this point is B f of B. Alright, so your theorem just says that the slope or the derivative at C, which is the slope, remember the slope of the tangent right here. The derivative, I'm trying not to mess this up. The derivative at C is equal to the slope of the secant line, which is your f of B minus your f of A over B minus A. Okay? And that's basically it for the mean value theorem.